Hello and welcome to the Answer Series Natural Sciences videos based on our study guides. In this video, we will work through a typical exam question based on the content we have covered during this topic. We will start by reading and unpacking the information provided in the question's introduction. A learner investigated static electricity. First, she used rubber gloves to rub a glass rod. After the glass rod was electrostatically charged, she then brought the glass rod close to a neutral plastic balloon to see how they interact. X shows the electrostatic charge of the rubber gloves before rubbing, and Y shows the electrostatic charge of the glass rod after rubbing. So this question gives us a written account of the learner's experiment as well as a visual summary of what happened. Pause the video here and try to answer the questions yourself before we work through them together. Question 1. The rubber and glass are electric insulators. Define this term. This should be an easy question to answer as it is one of the definitions you need to remember from your theory notes. An insulator is a material through which electric charges do not flow freely and that accumulates static electricity. Question 2. Name the force that is created when two surfaces move over one another or are rubbed together. And remembering your theory content, this force is called friction. This is the force that helps create static electricity, as the rubbing action or the movement of surfaces over each other allow for the transfer of electrons to take place. Question 3. What does the following represent in part X? The positive and negative symbols. So X is showing us a simplified version of the electrical charge of the atoms on the surface of the rubber gloves. The positive and negative signs therefore represent components of an atom that have those electrical charges. Remembering the structure of an atom, you'll recall that the positive charges are called protons and the negative charges are called electrons. Before rubbing, what was the electrostatic charge of the rubber gloves? To answer this question, we merely need to look at the section of the diagram that occurs before the arrow indicating rubbing. Here we can see part X of the diagram that shows the electrostatic charge of the rubber gloves before rubbing, exactly what the question is asking us to provide. Now we need to look at the number of positive and negative charges inside the simplified atom diagram to determine the electrostatic charge. We can see 6 positive charges or protons and 6 negative charges or electrons. This means that the rubber gloves are neutral before rubbing or friction, as there is an equal number of protons and electrons in the atoms on its surface. Plus 6 plus minus 6 gives me 0, so the rubber gloves have no electrostatic charge before rubbing, and that is what we call neutral. Question 5 asks us to explain our answer in question 4, which is what we just did. And this is very typical of scientific questions, where the thought process involved in getting to the answer of one question is often asked in the next. In order to determine the electrostatic charge of the rubber gloves before rubbing, we had to compare the number of protons and electrons at X in our diagram. And because we noted that there were 6 of each of these, in other words, an equal number of protons and electrons, we can therefore say that the rubber gloves were neutral before rubbing. So the key phrase in your answer should be that there is an equal number of protons and electrons. That is what makes an object neutral in charge, as the positive and negative charges cancel each other out. Pause the video here and try to answer the questions yourself before we work through them together. Question 6 asks us to study part Y in the diagram and determine the electrostatic charge of first the glass rod after rubbing and then the rubber gloves after rubbing. So for question A, it is merely a fact of looking at the picture provided and determining the balance of protons and electrons in the atoms of the glass rod's surface after rubbing or friction. That is actually shown in part Y of the diagram. So here we see that after rubbing, the glass rod has 4 positive charges or 4 protons and 2 negative charges or 2 electrons. This means that after rubbing, the atoms on the surface of the glass rod have fewer electrons than protons, and therefore its overall charge will be positive. Question B asks us to determine the charge of the rubber gloves after rubbing, which is not shown in Y on the diagram. All we can see is the glass rod. So we have to look at what happened to the glass rod in order to determine what happened to the rubber gloves. They were the only two materials experiencing friction, and therefore whatever electron transfer occurred had to have occurred between them. So we've already determined that after rubbing, the glass rod has a positive charge. We know that the number of protons in the atoms of an object cannot change. Protons cannot be transferred to or from the atom, so they will remain the same. So the 4 protons we see after rubbing in the glass rod's simplified atom means that there were 4 protons before rubbing as well. If we consider that all atoms and therefore all objects are initially neutral, this would mean that before rubbing, the glass rod's atoms should also have had 4 electrons, which then made it neutral before friction. However, at Y in the diagram, we see that after rubbing there are now only 2 electrons. So that implies that the glass rod has lost 2 electrons. From this, we can therefore conclude that those 2 electrons were transferred to the rubber gloves during friction. And because the rubber gloves now gained these 2 electrons, they will have more electrons than protons after friction, and therefore an overall negative charge. So even though we cannot see a simplified version of the atoms of the rubber glove's surface after rubbing, we can make conclusions about its electrostatic charge based on what we see happened to the glass rod. Question 7 asks us how many negative charges were transferred from the glass rod to the rubber gloves. So we've already answered this question by working out our answer to the previous question, and that is 2. The glass rod has lost 2 electrons during friction, and the rubber gloves gained those 2 electrons. Question 8 says to choose the correct word between brackets. After rubbing, the rubber gloves and the glass rod have unlike charges. Therefore, they will attract or repel each other. And this is a very strategic question because it just helps you to confirm your answers in question 6A and B. If you struggled with question 6, here the examiner now tells you that after rubbing, the rubber gloves and the glass rod had unlike charges. So you can see that in question 6A, we determined the glass rod had a positive charge, and 6B, the rubber gloves, negative after rubbing. And that confirms this statement. Remember that unlike charges are also called opposite charges, and an easy way to remember how opposite charges interact with each other is to remember that opposites attract. Then the last question says, when the learner brought the glass rod close to the neutral balloon, the balloon was attracted to the glass rod. So that is what the learner observed, which is also mentioned in the intro of the question. They told us that was her goal, to see how the glass rod and the balloon would interact. Now they ask you to explain why this happened by referring to the charge distribution on the balloon's surface. So this is a higher order question that now requires of you to remember what you've already concluded happened to the glass rod and how that is going to influence a neutral object, in this case the balloon. First, you have to remember that we just concluded that the glass rod had a positive electrostatic charge after it was rubbed with the rubber gloves. So you basically have to explain how this positively charged glass rod will now affect the charge distribution of the neutral balloon. And this is the opposite of the scenario that we discussed in this video on static electricity. So go and have a look at it. Now the question states that the balloon ended up being attracted to the glass rod. We know that unlike or opposite charges attract each other, so that would mean that the side of the balloon that's being attracted to the positive glass rod would have to have been negative. So how does this side of the balloon closest to the glass rod get this overall negative charge? And the answer is through the electrons in the atoms of the balloon's surface. The positive charge on the glass rod attracts the electrons in the atoms of the balloon's surface. This causes the electrons to accumulate on the side closest to the glass rod. In other words, that side will obtain more of an overall negative charge. But then what happens to the other side? Remember that there are protons in the atoms of the balloon surface too, and they are positively charged. These protons will orientate more towards the far side of the balloon, away from the glass rod, as the glass rod is also positive, right? So they kind of repel one another, giving that side of the balloon an overall positive electrostatic charge. Because the side closest to the balloon now has a more negative charge and the glass rod is positive, these unlike charges will attract each other and the balloon will move towards the glass rod. A question like this could count anything from 4 marks and up, and you would definitely have more than 4 places to get those marks. So for questions that require you to explain how electrostatic charges interact with each other, always remember to first state the initial electrostatic charge of the object or objects involved. In this case, only the glass rod had an initial electrostatic charge. Then mention which charges are like or unlike, and lastly, state how these like or unlike charges will interact with each other to then either cause attraction or repulsion.
If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.